Hi, you guys. What we're going to try to do now is move on to section 1.6. And if you want to follow along in your book, okay, this is going to be the first 2 pages in lesson 1.6. So this will be part 1. And just so you know, these are pages 48 to 49 in your textbook. As always, I'm going to start with my name on my paper. Okay. Oh, whoops. Oh, I don't want to do delete. So I started by typing in our objective, which is to know the precise definitions of, but I somehow managed to put my arm on this, so sorry. So definitions of angles based on undefined notions of points, lines, planes from last week. So hopefully you have this in front of you. We're going to talk about the word adjacent. An adjacent angle is two angles that share a common vertex and side, but no common interior points. So adjacent means right next to each other. So angle 5 is right next to angle 6. They have one common side. As you can see, it's the blue side, but there's nothing from the inside of 5 that's also in the inside of 6. Now, complementary angles, you probably already know this, but they're cute little angles. They're two positive angles whose whose measures have a sum of 90 degrees. And supplementary, also you probably would have gone over this previously, are two positive angles whose measures have a sum of 180. So if we know that vocabulary, boom, we're already done with that. Remember, this is a reminder, complementary and supplementary can be adjacent or non-adjacent. So they don't have to be connected like this first one. They can be disconnected. All it means is that they add up to 90 or 180. So if I look at these examples here and I want to name a pair of complementary angles, then one angle is BAC and another angle is RST. And if you wanted to write also, it's because 37 degrees plus 53 degrees equals 90 degrees. That's why we call them complementary. For a supplementary pair, we're going to make sure we write angle CAD and angle RST, because CAD is 127 and RST is 53, and when you add them together, you get 180. And then the one pair of adjacent angles here, adjacent means they have to actually be connected. And so that's going to be angle BAC and angle CAD. Notice they have that A in common. All right, so if you think about this, our FGK and KGH adjacent. So if I were you, I would just trace it. So FGK and KGH adjacent. So of course you would say yes, because they share a common ray. And nothing else is like on the same side, right? They share a common ray and they have no interior points. Okay, so for the second one, our KGH and LK, are those adjacent? Do they share a common ray? Of course, we would say no, they do not share common ray. Sorry, I'm just going to erase that. Whoops, too big. And then our, let's try it again, FGK and FGH adjacent. Are they adjacent? No, they're not. Okay. No. They do have a common ray, obviously, GK, but FGH has interior points that are also in angle FGK. So that sort of ruins the definition for us. Okay, so now we're going to go on to the next page. If you're following with me and you printed it out, turn it over otherwise. We're going to do some examples here now that we know what kind of angles we're talking about. So, number one thing to do, read the directions. So, angle 1 is the complement of angle 2. Measure 1 is 62 degrees. Find measure angle 2. I've got to know what it is I'm doing. And it says draw a diagram. So, what this means is that it's a sum of 90. That means I'm going to have a right angle, and I've got 1 plus 2. It says angle 2 is like 62 degrees. Or no, it says angle 1 is 62. So let's say this is angle 1, which I know is 62 degrees, and this is the measure of angle 2. Well, if I have complement, that means I can write angle 1 plus angle 2, which of course I'm supposed to write the measure of angle 1 plus the measure of angle 2 equals 90. You can write that because of the word complement. And then you just plug in 62 for 1, measure of angle 2. And so you will subtract 62 from both sides and you get 28 degrees. And lo and behold, that's what I was supposed to find. So I did the angle and I did the diagram. Now I can go on to the next one. Number 5. Angle 3 is the supplement of angle 4. Measure of 4 is 47 degrees. Find M3 and draw a diagram. Okay. So this means sum of 180, which means I'm going to have a straight line basically. It's telling me that the measure of angle 4 is 47 degrees. So it's going to be like, over here somewhere. And this is 47 degrees. And then so this is going to be the measure of angle 3. That'll be my picture. The definition of supplement means I can say that the measure of angle 3 plus the measure of angle 4 equals 180. I'm told 4 is 47, so I can put a 47 here. I'm going to subtract 47 from both sides, and I get 133 degrees. Well, might as well make it my pretty green color. Okay, box. I'm done with that. Now I'm going to move upward to do 3 more examples, 6, 7, and 8. Now, we're going to use these 3 words, complementary, supplementary, and adjacent, to, again, draw, not draw a picture. We don't have to draw a picture on these. Use the definition to write an equation. So, LMN and PQR are complementary. Okay, remember that means they add up to 90 degrees. find the measures of the angles. So we're going to start by writing an equation. And here's my equation. LMN plus PQR equals 90. That's where you start. You don't have to do anything else. Start there. Now you're going to plug in what they're equal to. So LMN is equal to 4x minus 2 degrees. And PQR is equal to 9x plus 1 degrees, and that's 90. So now you can combine your like terms, your x's together, your constants together. So you'll get 13x minus 1 equals 90. You're going to add 1 to both sides, and you're going to divide by 13. So I found x, but I still have to go to find the measures of the angles. So you come over here, this is why I have space. Then measure of angle LMN equals, I've got x, so I'm going to plug this into 4 times x minus 2. So x is 7. That's going to be 28 minus 2, which will give me 26. And measure of angle PQR is equal to 9 times x plus 1. X is 7. So this is 63 plus 1. That'll be 64 degrees. Now, because I am a conscientious person, I'm going to come over here and I'm going to check my work. In other words, they need to add up to give me 90. So I'm just going to check that 26 plus 64 gives me 90. Yay. And then I can give myself a happy face because I know I'm right. I can go on to the next one. Number 7. Angles 1 and 2 are supplementary. So again, that means 180 degrees. Find the measures of the angles when 1 is this and 2 is that. So again, this says we can write, the definition of supplementary says we can write the measure of angle 1 plus the measure of angle 2 is equal to 180. We can write that equation because of the definition. Now 1 is 7x plus 13. 2 is 25x plus 7. And now we can combine our like terms. The x's can go together. The numbers can go together. So I have 32x plus 20 equals 180. I'm going to subtract 20 from both sides. I'm going to divide both sides by 32. And I get x equals 5. Now I can find the measures of the angles. So again, I'm showing all my work. So the measure of angle 1, angle 1 is equal to 7 times x plus 13 from here, and x is 5. So this is, let's see, 35 plus 13, that's going to give me 48. And measure of angle 2 is going to give me 25 times x plus 7 from here. And that's 125 plus 7, so that'll give me 132 degrees. I box my answers, make sure I have them correct, and then I'm going to check it. 48 plus 132. It should add up to 180, and it does. Yay, give yourself a star. Congratulations. So we did a complementary, we did a supplementary, now we're going to do one more. And imagine that's probably going to be adjacent, if I can scoot it up here. Oh, too far. That's okay. So there we go. When viewed from the side, the frame of a ball return net forms a pair of supplementary angles with the ground. Find BCE and ECD. So here's BCE and here's ECD. So I have those two. But again, the definition of supplementary angles means if I add those two angles together, the measure of BCE plus the measure of ECD, it equals 180 degrees. There you go. And they're also adjacent. So BCE is labeled 4x plus 8. ECD is labeled x plus 2. Here we go. Our like terms and our combined constants give us 5x plus 10 equals 180. I'm going to subtract 10 from both sides. I'm going to divide both sides by 5, and I get x equals 34. Now I can't, finish until I plug it in here. So BCE is equal to 4 times the x I found plus 8, and the x was 34. So if I multiply those, that's 136 plus 8, so that gives me 144 for the big one, which looks, it looks like it's big like that. And then ECD is x plus 2, so it's 34 plus 2, 36. I box my answers. That is what I'm supposed to do, and then I'm going to check it. 144 plus 36, and lo and behold, it's 180 degrees. Yay! And we can be done for now. Okay, so that's lesson 1. You should be able to now start your other things, and I am going to stop recording now.